Okay, this is a stationary points question, which is a higher skill, but as we can see the function is e to the x times sine x, so it's a product, and of course we've got our e in there as well. So first thing we're going to do obviously is differentiate, because we want to find when the gradient is 0. So it's a product rule, so I'm going to say u is going to be e to the x and v is going to be sine x. That means u dash is e to the x and v dash is cos x. So our derivative is u dash v plus v dash u, so it's e to the x sine x plus e to the x cos x. Factorise to get e to the x brackets sine x plus cos x. Now if I want to find stationary points, I want to know when that's 0. And that means that either e to the x equals 0 or sine x plus cos x equals 0. Now e to the x, there's no solution here, because that would be ln of 0, which is not possible. So there's no solution here. So we're looking at the sine x plus cos x. Now, I don't know off the top of my head when sine x plus cos x equals 0. So I'm going to have to manipulate this and use little trig identities. So I'm going to say sine x equals minus cos x. I'm going to divide both sides by cos x, which will give me sine x over cos x equals minus 1. And so that means tan x equals minus 1. If tan is negative, it's going to be in one of these quadrants here. And so we should end up... now if tan x was positive 1 in this quadrant here, it'd be pi over 4 or 45 degrees, so you'll know that from your exact value triangles. So pi over 4 is the acute angle, but we're actually not interested in that one. We want to see what happens in the second and fourth quadrants. So in the second quadrant, x is going to be pi, take away pi over 4, which is going to leave us with 3 pi over 4. And in the fourth quadrant, it's going to be 2 pi, take away pi over 4, which is 8 pi over 4, take away pi over 4, which is 7 pi over 4. And so that's the two x values. Okay, so we have the x values, 3 pi over 4 and 7 pi over 4. We're going to substitute those into the original function, which is e to the x sine x, to give us the corresponding y coordinates. We just go back and have a little bit of a look at our acute angle was pi over 4. The sine of pi over 4 is 1 over root 2. We know that from our exact value triangles. So in this quadrant, I'm going to have a positive 1 over root 2. In this quadrant, I'm going to have a negative 1 over root 2. So when x is 3 pi over 4, y is going to be e to the power of 3 pi over 4 multiplied by 1 over root 2. You can't evaluate this in your calculator to give you a decimal number. It's 7 point something. I'm just leaving it in this form for the moment. The second point occurs when x is 7 pi over 4 and y becomes e to the power of 7 pi over 4 times negative 1 over root 2, which is minus e to the 7 pi over 4 over root 2. Again, you can get yourself a decimal number for that. We are not asked in this question to state the nature of the points, so I'm not going to go on to do a second derivative and work out its maximum, minimum point of inflection, etc. I'm just going to leave it there for this question.